Right, this says right here, I didn't write it down, but it says write this in logarithmic form. Okay, so this is just, I mean, you're going to have to do this, changing things to logarithmic form for a lot of other problems. This one, that's the only thing they're asking you to do. They're not asking you to solve for anything. There's really nothing to solve for. Okay, they're just asking you to change it from exponential form to logarithmic form. So what do? First thing I do is I say log base, what? What's our base? It's 5. Of what number? This is where it gets confusing. Some people think you put a -4 here. Some people think you put this number here. Which one?
The 1 over something.
That's right, because remember what logarithms are. Logarithms are exponents, okay? So this logarithm equals an exponent. So what goes over here? The exponent, the -4. So what goes here? 1 over 625.
What is the formula?
It's, let's see, what do we put? We put b to the p, I think, equals n. Is that the letters we used? Okay, because b is for base, p for power, n for number. All right, so if you start with this, then what do? We go log base, what? What's our base? Well, it's obvious because the letter b of the number n equals the power equals the exponent. Remember, an exponent is a logarithm. This is your exponent, isn't it? And that's equal to what? It's equal to a logarithm. So the exponent's always equal to a logarithm. That's one thing that you should be able to remember. All right, let's look at number 6. Number 6 is actually really easy if you understand what's going on. Let me just show you a little background. We want to find out the value of this. Now, you could just actually look at this without doing any math whatsoever and tell you what the answer is, couldn't you? You couldn't? No, plug in a calculator. No way. Just look at it. In half a second, you know what the answer is. Jordan, what's the answer? Luke, what's the answer? Somebody tell me. It's 8. Yeah, just looking at it. No. Don't use a calculator. You kidding me? Look, it's 8. That's all it is. It's just 8. I can look at it because the log base 6 and this base 6 go. All right. Now, why do they go? Well, they go because of this. If you wanted to do this, you could. Watch. Change it from logarithmic form to exponential form. Now this is like reinventing the wheel. You don't have to go through this all the time. I just look at this, save me some time, I just write down 8. That's my answer because I know the log base 6 and this 6 will eventually kind of cancel each other out, if you want to call it that. But watch. I could write it 6 to the x equals what? 6 to the 8. Do you see how that works? No calculator needed. The bases are the same. What do you do with the exponents? Set them equal to each other. X is 8. But why go through that? You can just look. When you have a situation where you have log base 6 and then a big old base 6 right here, what happens to them? They basically go away. What's my answer? It's just 8. So everybody should just be able to look at this and just say, oh, it's 8, and that's it.
So if the log number and the base are the same, then it cancels.
That's right. Yep, then they go. All right? Makes it really easy. All right, what about this thing right here? We're going to put x. They don't put equals x, but we're going to, because what are we going to do to this? We're going to change this. Actually, we could just do this in a calculator. What do we call this thing? There's a rule. There's a, change of base theorem. Do you remember that rule? Okay, what's the change of base theorem say? It says I can put log of, right, the bigger number, 128, over log of 8. I can do this. Now you use your calculator on this one. Right, you just plug and chug into a calculator, and let's see, you get about 2.3 something. Yep, 2.3333. We'll just go 4 decimal places. Okay, that's all there is to it. You could do it another way. That's the easiest, quickest way. You could change this like I was going to do earlier. You could change this 8 to whatever power. And then try to get the same bases and blah, blah, blah. You don't have to do all that. I would just, if I was to do this, the quickest way, just throw it into a calculator, change a base theorem, and you're good to go. We can do a few more. All right, here we go. We're trying to solve for x. It's in logarithmic form, so the way I want to do this is to change it to exponential form. So we start with a base, 64, take it to the power, which is 2/3, and that equals the number, which is x. So if I can figure out what this thing is, then I can find what x is. Do you remember how to do this? They rigged this thing, so it's 64 to the 1/3, right? I take 1 over whatever the denominator is to this power. But then what do I have to do to it to make it equal to this? Take it to the second. Do you remember that? Okay. Because look, it's the same thing, isn't it? What do I do with the exponents? Multiply them together. What's 1/3 times 2? It's 2/3, isn't it? So it's the same exact thing. But why did I write it like this? Because 64 to the 1/3 is something I can figure out. What does it mean to take something to the 1/3 power? Is it square root it? Well, say it the right way. It's not square root, it's cubed root. It's cubed root. What's cube root of 64? What times itself times itself times itself? 3 times. 4, right? 4 times 4 is 16. 16 times 4 is 64. So yeah, there's a cube root button on your calculator. Okay? But on this one, you don't need a calculator to do it. Okay? Yeah. But you can. There is a cube root button. Well, you might not have a cube root. Depending on what calculator you have, some calculators have something that looks like this. Okay? Like on the one that you're showing me. Right? Don't you have a little one like that? Yeah. You have a button that looks like this. So you would hit 64, then you'd hit this button, all right, and then you put 3, okay, and because that takes the 3rd root of 64, and you should get a 4. Try it. This is 4 what? 4 squared. 4 squared is 16, and that's your answer. So that's what. No, you can. I'm just trying to. I'm really trying to give you shortcuts. When I say don't use a calculator on this, actually, I mean, by the time you pull out the calculator, try to figure out where the buttons are and all that kind of stuff, you could have been done. I'm just trying to get you to visualize, just understand the math a little bit more than just plugging stuff in a calculator. Okay, that's why I'm harping on not using a calculator. Can you use a calculator on this? Absolutely. If that's the only way that you can do it, then go ahead and do that. I'm just trying to show you that the cube root of 64 has come up several times, a whole bunch of times, and you should be able to do that in your head. And then 4 squared is easy. That's just 16, and you're good to go.
How do you do it?
Okay, number 9. Well, I got time. This will be the last one anyway, so might as well just write it down. So look how simple this is when you first look at it. Why do I say it's simple? Not just because I'm the math teacher and I know what's going on. It's because what? That's right, the logs. Right. Basically, they cancel out. Good. You're listening, Danny. Good job. I like to say log of this equals log of that, so this equals that. All right? It's not a very mathematical thing, but it makes sense to me, doesn't it? So that means if those are the same, look, these are just equal. They're not necessarily equal to each other. It's less than or equal. And then you just do this. Let's do this real quick just for the video. Right? 3x minus 2. Subtract a 3x, we get negative x. Subtract a 5, you get a negative 7. Less than. We did this earlier, didn't we? So we got to change the inequality. Greater than or equal to what? 7. On these, you got to make sure that your arguments are going to be positive. Does 7 make everything in here positive? Yeah, it makes it positive, so that's fine. That's my answer, and that's it. Okay.